This is a Friday Shoes production. This is lesson 9-1 on page 464. The target is, I can write algebraic expressions to determine any term in an arithmetic sequence. Take a look at this pattern. Talk about sequences. Do you see the one triangle? It takes 3 toothpicks. 2 triangles takes 5 toothpicks, and 3 triangles takes 7 toothpicks. Hopefully you can see that. Well, the number of toothpicks needed for each pattern form a sequence. A sequence is an ordered list of numbers. Each number is the list, or each number in the list is called a term. An arithmetic sequence is a sequence in which the difference between any 2 consecutive terms is the same. And hopefully you can see that this sequence actually goes up by 2 each time. We call that the common difference. Cool. Well, let's go on from there. Identify arithmetic sequences. State whether the sequence 17, 12, 7, 2, -3, and so on is arithmetic. If it is, state the common difference and write the next 3 terms. Well, let's take a look. Doesn't it go down by 5? It sure does. So, therefore, we would say what? The terms have a common difference of -5, so the sequence is arithmetic. And continue the pattern to find the next 3 terms. Well, what are the next 3 terms? Well, that's pretty simple. You just subtract 5 again. And then you get -8, -13, and -18. So that's the next 3 terms. How about you stop, pause, and then come on back and see how you did? Ready, set, go. State whether each sequence is arithmetic. Right, yes or no. If it is, state the common difference and write the next 3 terms. All right, I look at this pattern right here, and I see that it has a common difference of 4. So therefore, yes, it is a arithmetic sequence, and the common difference is 4. Now, of course, just add on 4 a few more times, you get 22, 26, and 30. Pretty simple. How about the second one? -4, -8, -16, -32, and go so on. Yeah, I notice it goes up or goes down by 4, then down by 8, then down by 16. So guess what? Now, this is not an arithmetic sequence. It's something totally different. All right. Describe an arithmetic sequence. Write an expression that can be used to find the nth term of the sequence of the perimeter of squares, 4, 8, 12, 16, and so on. Then write the next 3 terms. All right. Let's use a table. So when you take a look at the table, you can see 1, 2, 3, 4. Those are the number of that's the term number. And then the perimeter is the 4, 8, 12, and 16. So they're telling you that the terms have a common difference of 4. And also, each term is 4 times its term number. So if you take 1 and multiply it by 4, you get 4. If you take 2 times 4, you get 8. See how you're getting these numbers here? 3 times 4 is 12, and so on. Kind of neat. An expression that can be used to find the nth term is 4 times whatever the term number is. Again, these are the term numbers. Should just take 4 times that term number. Pretty simple. So the next 3 terms are going to be 4 times 5, which is 20, 4 times 6, 24, and 4 times 7, 28. All right, how about you give it a shot here? Pause the video, try these, come on back, see how I did. Write an expression that can be used to find the nth term of each sequence. Then find the next 3 terms. All right, C. You take a look at it. I've actually made it a table for you. So the first term is -2, second is -4, the third term is -6, 4 is -8, and so on and so forth. So hopefully you can see that the common difference is -2. It actually is going down by 2. So if you take common difference and multiply it by its term number, you should get the next one in the list. So if we do that, you can see that the next 3 are going to be, the terms are going to be 5, 6, and 7, and they're going to be -10, -12, and -14. How about D? These are fractions. That doesn't make it any harder. Just the first term is 1/6, the second term is 1/3, and that's all they're doing is adding 1/6, I noticed. So that is our common difference. So what we would do is take 1/6 times the term number to get to the next one. And when you do that, here are the next 3. You got 5, 6, 1, and then 1 and 1, 6, which is also 7, 6. All right, here comes the cool thing. You definitely want to write this down in your notes. Inside this box is the fast way to do finding any term in an arithmetic sequence. So to find the nth term, all you have to do is take the common difference times the number term you're looking for, plus the 0 term. And the 0 term is the term right before the first term that you see. So let's do an example, and then hopefully you'll get the gist of what we're doing. So we have 8, 13, 18, 23, and we want to find the nth term. Well, what's the expression to do that? Here it comes. First off, we need to find the common difference. That's 5. The next thing we have to do is find the 0 term, and that's the term right before the first term. 8 is the first term, so the 0 term is right before it. And if we followed the pattern, we would actually subtract 5 to get to that 3. So the 0 term is 3. Then you plug it into this formula, which is the one in the box up there. The nth term is the common difference times the term you're looking for. In this case, you can see they're actually asking us for the 1,000th term. So that would be 1,000, and then plus the 0 term, which would be 3 here. So let's plug those numbers in. 1,000th term is going to be 5 times 1,000. Of course, that's 5,003. So the 1,000th term will be 5,003. That saves a lot of time because we don't want to sit there and write 1,000 terms out. All right, how about you give it a shot? Come on back, see how you did. It says, write and solve an expression to find the nth term of each arithmetic sequence. Here the sequences are. I see that I have a common difference of 5, and then I have a 0 term of -1, so I plug those in to this wonderful formula. So the 12th term will be 5 times 12 plus -1. Again, that's the common difference in the 0 term being put into that formula. And then, of course, that's going to be 60 minus 1, which is 59. All right, how about G over here? Well, I see a common difference of +4. Then I also see a 0 term of -24 if I go to the left. So I take the formula, plug the numbers in, and I've got 80 plus -24. When I do 4 times 20, that's 80. And that gets you 56. So the 20th term will be 56. All right, let's take a look at this last example here. Which expression can be used to find the nth term in the following sequence where n represents a number position in the sequence? Well, all you have to do is plug the numbers in and see what happens. So I'm going to take 1 and plug it in for this first one here. So it's 1 plus 2. That equals 3. Okay, that gave us 3. That's cool. I'll take the next one, 2. Plug it in here. Again, plug it in here. So it's 2. What is that going to equal? Now it's 4. Oh, wait, that's not 4. That's 5. So it can't be this one. How about this B? Let's try that one. Plug it in there. Do this one in red. Take 1, plug it in here. So I got 2 times 1. That equals 2. Well, we're supposed to get 3. So it can't be that. How about C? Let's take our 1, plug it in for n here. 2 times 1 plus 1. That equals 3. That's good, because that's what we're looking for. How about 2? Plug 2 in. That's 2 times 2 plus 1. That's 5. Hey, that's what we're looking for. Take 3. 2 times 3 plus 1. That's 7. Hey, that worked out too. Oh, maybe this last one will work out. It does. Look at that. I took 4, plugged it in, and got 9. So there you are. C is going to be your correct answer because that fits the table given. Don't forget, you can rewatch this video, or you can look at the examples in the book, or you can look at the personal tutor videos online on the online textbook. And this has been a wonderful Friday Shoes production.